Hello, everybody. How are all of you? Sorry, Tyler. I just saw that super last minute, and I should have rolled it right before that. You know what? You know what? I just you're so great that this is Tyler, by the way. I'm not gonna say more about Tyler and his awesomeness, but just for Tyler, that's for you, Tyler. so, um, it's not a natural 20, though, I have to confess. I just totally positioned it. So, hello, everybody. We have Jessie on the line. It's the Enceladsaurus. Did I say it right?
Yeah, you got
Oh
it.
my God. Sweet. Okay. And she's here because we're going to be learning C. She's had enough of this whole manage types thing from Python and all that silliness. We're going to get down and dirty with memory, and we're going to manage it ourselves because we do that. we're we're just gonna torture ourselves. No. Okay. And hello, Strophium. How are you? And have fun. Yes. I'm sure she's gonna need it because we're gonna get into some fun stuff. So let me show you kind of what we have in store for you tonight. So as those of you who were following along before, we already went through topics 1 and 2. And I am, by the way, just evolving this. This is from the website, Coding with Some Guy. Sorry about the site, Tyler. By the way, just so you know, Jesse, Tyler is the most ultimate guru of CSS, like in existence of person kind.
Oh wow.
So
That's quite the endorsement.
I have only the greatest words to say.
The next one.
Yes, he
You gotta
totally
put it
just,
in something. I
that
mean,
one stat is like through the roof. So it is visual. It is like physical pain for him to look at my web pages. And Tyler, I'm sorry. I threw it together really fast one day. But anyway, I spent a lot more time focused on what's on that page rather than how it looks. So I'll take small comfort in that. But it is a work in progress. So I'm just going to keep updating this as we sort of go along and realize what is helpful to a programmer coming from Python, which is where Jessie does most of her astrophysics. And that's okay. Tyler says content is king, so we're okay. I guess that's all right, endorsement wise. All right. So for tonight, we're going to be getting into. So we're the Enceladsaurus and I are going to be experimenting with a new format. We're going to go hardcore on the learning in the first hour, and then we're going to go as questions and topics come up. We're going to go. I'm just going to write them down over here on my trusty notepad, which I have labeled as part 2, topics and scotch. So that's we'll get into the all sorts of random stuff about computers in that segment. So for right now, we're going to focus on topic 3, which is really about the other loops, and we're going to get into some of the fixed sizes because Jessie needs to manage the memory herself. And I think once she's done enough of that, she's going to realize how great Python is. So.
I already think Python's amazing.
Yes, Jessie's tangent corner, Strophium says. Very nice. And yeah, we're all about that. We're just, I confessed to her that I would feel really terrible if I was teaching her C and she walked away not knowing C because we had too much fun talking about 2's complements and all the other base 20 numbering systems and all the other things we were getting into. So why not both, right? I mean, that's the answer. So I've already got the glove on. We're ready to draw. And I think with that, let's get going. So let's switch over to our editor here, which has been evolving a little bit. I just pushed almost the most recent version of the code. We're in C mode tonight. Tyler, in particular, you're going to love this because this allows you to pair program, group program over the internet with I have pluggable authentication. I'm not going to go too much into this, but basically I call this the multi-user-pad. And we've got our whiteboard coming through up here so that Jessie can see it in real time. Her audio's in real time. There's a little bit of lag on stream. And what's up, Fafi? Hello. So we're in C mode, Fafi. Unlike earlier today, we're not doing our Python or JavaScript modes. And yeah, we have a new feature that Jessie just discovered in warm-up, which is errors. Look at this beautiful error. So big improvement from last week. So we can actually see errors when we get around to that. So before we can type errors, let's do a little bit of theory. So I am going to switch over to whiteboard full-on mode. You can feel free to watch wherever you want, Jesse. All right. So today we're going to be talking about, what are we talking about? We're going to be talking, let's go red here in honor of Tyler, who's here. So we're going to talk about while loops, and we already know about the three-part for, three-part for, not for, and we're going to talk about the do while and why you should never use it again. So that's kind of our most important thing to learn from there. In the second part, we're going to talk about fixed sizes. And, because that's the second part, I'm going to just green that up. So we're going to talk about fixed size portable types. And this is going to be important because so far we've been using kind of the classic styles of defining how we want to deal with memory. So we're going to move into the new age. And the new age is all about, in C, we're going to be doing the new age, meaning C89, or the 1989 standard of C, which is brand spanking new. There's a C11, and we're going to be kind of using that too and some other fun stuff. All right, so without further ado, let's get back to our redness. So what do we do with a while loop? Well, it's not that different from the for, right? So in our three-part for, unlike in Python, we have sort of our initial case. I should actually use the labels that Jessie likes to use. She calls this start. I'm going to rename this middle one to during. It's just sort of like the end, or rather the inverse of it. Not the end. And the iteration, the iterate case. So this is, and just to review, this is basically how we're going to get started with our loop, whatever we have to set up in the beginning. This is how we tell if we should keep going each time we go through the loop. If this is true, then we're going to keep going. Otherwise, we're going to stop. And this is what we're going to do each time through the loop. So in our regular example in C, this usually looks something like for int I equals 0. So we define an integer 0. We say as long as I is less than 5. And take I, I'll write it out the boring way, and take the old value of I and add 1 to it and store that in the new value of I. Cool. And then we use braces because this is C and we have to specify blocks this way. We don't count on indentation. Okay. And Nathaniel's mentioning we might as well go C18. Wow, this is getting some pretty crazy stuff here. There's all this newfangled C. I don't know what Nathaniel's talking about here. Oh yeah, that's right. We were doing C99 before. I'm so sorry. I don't want to be talking about C89. I want to be talking about C99. Okay.
We should probably pick a different variable other than I, because I don't know if anyone else is maybe other people are having less issue, but when it's all written out like that, I'm having trouble telling the difference between the I's and the semicolon. Thank you.
Okay.
Perfect. There we go.
I don't know how much my handwriting is. Actually, that J looks exactly like a semicolon too.
That one, at least it's white, so I can tell.
It's just a ground up rewrite. This is Z and Z and Z and Z. There you go. That doesn't look like anything else. Okay. And what's up, Loafbone? How are you doing? So just use capital I hand. No Nightshade, dude. No trolling this early on. Okay. So this was our
I don't know enough to be trolled yet.
Don't troll her yet. Let her get the crack first. Okay. So, okay. All right. So that's enough of the three-part for. We can do a little bit of recovery reminders on that if we need to. So tonight we're going to be talking about the while. Let's start off with while. So
my least favorite loop.
While is really important.
Now, I hate while.
It's kind of funny in C because in C, you're allowed to leave any of these three parts. So we had like, what do you call it? Start, middle, end. Actually, totally wrong, actually, isn't it? So this was start, during, and the iteration. So any of these are actually optional in C. So if I want to build a loop that runs forever, I can just go like this. I could say for and put nothing in all of those moments, and this is just forever. Misusing like the for loop is like one of the greatest things that you get to do in C, but it makes the most unreadable code. So this is one way. What's a more proper way to do it? It's like, we could just say like while, and because I'm not really using any of these other parts. So this is a little bit naughty use of the for loop. But anyway, with while, all I have is just the condition. And the condition corresponds to the during again. So that's the same as in Python, right? So you have like your forever loop in Python looks something like while true, right?
Yeah.
All right. Well, that's fine. In the C version of that is you can say while 1, because there's no true and false in C because that type doesn't exist. So
wait, booleans don't exist?
There's no booleans in C. So
what?
Yeah. We went over all the data types the other day. We had int, we had char, there's variants.
Well, I'm guessing float is something, and we didn't go over that, so I just thought we hadn't got
float for floating point, double for double. I mean, there's the long version of the integer, and
how do you? No, wait, because when we were warming up, I used double equal sign somewhere.
Oh yeah, there's definitely Boolean arithmetic. Like there's double equals.
It's not a Boolean type.
There's greater than or equals. There's less than or equal. There's all this stuff, but it's sort of for the JavaScript people in here. It's kind of truthy. So it ends up being anything that evaluates to 0 is false, and anything that evaluates not to 0 is true. And this is kind of a very C world. So if you want to be naughty, you can use anything here for true. You could say like, if -1, and that'll work. So, oh hey, what's up, Drop Bear? Whoa, Morse code?
What? Hold on, it's been years since I played Nancy. That's the last time I learned Morse code. I learned Nancy Drew. I don't think I can.
Fafi, there's no triple equals in C. So no. Don't do that. I actually know Morse code, but that's for reasons that we're going to get into when I hooked up the telegraph key to Netflix. But, all right, so back to our while. Let's stick to this. So how much sense does this make to you? I mean, based on your Python experience. I'm guessing you've used whiles before.
Unfortunately.
Okay, so we can do our forever loop. If we do that, there's no way that you can stop your program. So I don't recommend you write an infinite loop tonight.
Yes. That I am aware of.
Drop Bear, that is correct. 0 is equal to false and anything else is true. Yes. Except in some functions where they return 0 meaning true, and that's annoying. But there were fights in the standard. But yes, generally speaking, when you're talking about conditionality in the language, then yes. Okay, so let's just do like, what do we do with our while loop? Well, normally I can write a W. So it's while something is true. Okay, and we just learned that true is kind of a little bit loosey-goosey in C, but so while something is true, do some code and have fun and do whatever, do the thing. And this will work, like this will just keep on running this as long as this is the case. So our only way to kind of control this is to sort of be careful about whatever this condition is. If we do write something like this, then you have no way to stop it. And I should really make a note that you're going to need a way to stop that. Stop.
I mean, that sounds just like Python.
Yeah, because this program doesn't do that. Oh, hey, you got a lot of people dropping by tonight. Okay, so great. We're going to use a while loop pretty much like a for now. We're not going to spend too much time with whiles, but I can tell you that like in cases where it's less about counting, while is usually more useful. Like for example, while, you know, stuff in the file. Parse file. So this would be the kind of case where you'd want to use a while naturally. Make sense?
That makes sense. Yeah, of course.
All right, and then I'm briefly going to mention the do while, which is just something terrible, and it was not brought over to Python, I believe, which is very similar to the while because the while goes at the end.
But you also crossed that out. So I have a note saying don't do that. Why don't we like do whiles?
Okay, do while, it was originally thought to be kind of a good idea. It ended up being pretty nasty because it ends up hurting reasoning. But let me before I get on its case, let me tell you what it does. Do while, just in case, this is more important if you run into it in somebody else's C code rather than you should ever be writing it yourself. Do while, basically, it's the same thing as a while loop, but we've inverted the position of the while on purpose because basically we're saying do this stuff in here first and then evaluate the condition afterwards.
Okay.
So it's kind of like a while, but you want to make sure that it runs at least once. So it, you know, again, valid C syntax, it's not a very commonly used operator. And due to the fact that like not a lot of programmers are comfortable using it, a lot of bugs have kind of crept into a lot of code because of the use of the do while. So it's one of those things where it's like, it sounds really neat and it's a lot of fun to use it a couple times. And then you're going to kind of realize like, like you're going to see it around and you're like, it's not really commonly used, but yes, it does get some use. I mean, it's, Loafbone, is the audio having issues? I mean, is it like both of us kind of crackling or? I don't know.
I'm having some issues every once in a while. You cut out a little bit, but it's not super, super bad.
Okay. Nathaniel kind of summed it up. It's been basically cut from pretty much every other language. It doesn't really do anything that you can't do with a while loop anyway. Right. I mean, like, so all you have to do is really just kind of play with your condition, or you could do it with kind of a for loop. So it ended up just being kind of language tax in that we had to support another construct, but it doesn't really functionally add anything that while or for doesn't do, with about the same like brevity. You know, it's not like it saves a ton of time versus using like a while or something.
Okay, that makes sense.
Yeah. So Drop Bear is asking, hey, have you gone through configuring a compiler environment? Drop Bear, no, but what I did do is I made this all. So that's actually part of why I built this tool in the first place, because that's a hard problem. So it's one of those things, like, to get this C compiler set up and get everything like kind of working. It's like some version of a C compiler is usually running on most systems these days, but like getting it to be stable and a certain standard and everything else, like that's actually kind of a lot of work. So I figured for like, you know, kind of people that are new to a given topic, that's probably not a great set of steps. I think it's better to kind of get in the language, and that's part of why I made this environment look the way that it does. So basically this is plugged straight into the compiler environment on the back end, and you know, we get our output over here. So we don't have to worry about tool chains, and we don't have to worry about all the other stuff that goes with setting that up. But I can tell you that if you're curious, I do set the environment up for you if you pull the project. So you can go into, this is on GitHub, coding with some guy. And if you go into this repo that I made up for the multi-user pad, there's this script in here that'll kind of do all the work for you if you happen to be running on an Ubuntu-like system. That's a huge task that you just mentioned, like across every operating system and different toolchain versions and everything else. And I'm not even beginning to start talking about cross-compiling. But anyway, let's not scare Jesse.
Oh boy.
So this does have my favorite line of code in it, I can tell you, because it has the I am crazy flag, which you have to set to yes. So you have to be crazy to run this thing. And I'm not. I think that sets the right expectation. Okay, so great. So while loops and do while loops and for loops all make sense?
Yes, I think so.
Okay. Mary Jo Stabler, what's up? How are you? All right, so we got Lopebone, we got, although Swift has a do while. Oh, I guess some places did bring it around. And
Lots
Ricky
of
Don
friends.
says we sound good. And Mary Jo Stabler's good. How are you? I think we're good. We're just getting into our groove here. All right. So let's just run ahead for the other part of the whiteboard stuff so that we can get all that out of the way. All right. No, I don't want to do that, OBS. Don't be a bad OBS. Okay, so let me, all right, here we go. Second part is really about fixed types. And, I think a pretty good way to guarantee that you forget everything that I just told you is that I should just go into this right now. So let's not do that. Let's do a little practice. Okay, so great. Your basic while loop has a form similar to kind of like what you were doing with your for loop. So your syntax, actually I should let you type. What does your for pseudocode look like? Hands off. It's not me. It's not a macro. Yes. And we get our block.
Yes.
4 score and 7. Yeah, Mary Jo Stabler's having some fun. Okay. And yes, by the way, Nightshade do, but I'm being careful on that one. So, okay. While looks more like
Yeah, exactly.
Okay, this is part of why I was trying to avoid the word while and I was trying to call it like during, but yes, it is very much the while like truthfulness. Okay, and yes, While My Guitar Gently Weeps, great song, by the way. I like where he went with that. I didn't know setting up correct flags very complicated according to you, or am I missing something here? Prayag, no, it's tool chains. Let's get into that in the discussion section. I'll throw that on the list. So tool chains. Okay. So in the meantime, let's so just to warm up, let's print out the first 5 numbers using a for loop.
Oh, okay.
Nice, Loafbone. I'm guessing that's probably related to the instability Twitch was having earlier with the reflection network and the way they were moving the streams around. Where did you get this habit?
You taught me that.
I taught you pre-increment.
Why? No, I don't want a pre-increment because I don't want it to. Well, you do want me to start with 0 or 1?
Mary Jo Stabler, we're doing C, by the way. Strophium's actually writing out the longer answer, but bugs are actually the reason that things changed across standards.
Because if we increment before, won't it go to 1 at the start of the loop?
Let's see what gets printed. Let's find out the answer to your question. We don't have to guess. We have a compiler. This is like I told Tien on stream the other day. She's like, how do I know the answer to this? And I was like, You know, it's like that scene in Harry Potter. Like, you're a wizard. You have a wand. You have a compiler. You can do anything you want with this thing. Build all the software in the world. You have something better. Okay. So it ended up working the way you expected or not?
No.
No. Yeah, it's kind of... Don't worry about it too much. Just let's get in the habit of using pre-increment. We'll get into reasons later.
Okay.
In this case, it doesn't really matter anymore in modern standards. Mary Jo Stabler, that's a longer... All right, I think chat's hungry for that one, so we'll talk about pre and post increment in the discussion part. Okay. So, yeah, great. Now, how do we get the first 5 letters? Looking good.
Yeah.
That's kind of awesome. All right, so we remember how to do some basic for loop stuff. Great. Now, how do we do it with a while loop?
I'm going to leave the for loop up just for a second.
That's totally fine. Strophium is correct, by the way. Iterators and, in particular, a lot of constructs that come in C++, it does matter a lot more. But let's... I'm going to kind of punt on that for the moment. So I'm just going to add in a new line so that you don't trip yourself up with that output. Okay, now I did tell you that we normally scope the int in C, but that's because we have an initializer in the for loop. Right?
Okay.
So in the for loop, we actually get to like set our initial values. This is not good in a while loop, however.
Because we can't really initialize it, right?
It's not an initializer. Yeah. Yeah, there's no initializer in a while loop. So you got to get rid of that int as well.
Oh, yeah. Thank you. Yeah, look at that. It worked.
That's pretty solid. And you managed not to do an infinite loop with it, which I'm really impressed with because I was getting that kill command ready. Okay. So, yes, this system, by the way, if you look in the code repository, does not have a lot of limit calculations. So, containers. Let the container do it, right? No, let's just be careful. So, okay, that's our
Copy
while.
this for my note.
How do you think you do the same thing with a do while? Like, say you want to run it once.
Oh, so in this case, no, so do this, and then the while comes up here, but then we need this. So it runs first before it iterates. So
I'm just going to hide your earlier output so that we only see one of these, and I'm going to give you a little clear here.
So if it runs once before...
What's I on the first iteration?
0. Until the end of the iteration, and then it becomes 1. So it's 0 when it goes put char, and then it runs the next line, which
then
adds
1. So it's 1 at line 19, right?
Yes, yeah.
And then what happens?
Well... So then
it evaluates
then it hits
the while.
Yeah. So I mean, functionally for this loop, I think it'll, right?
I'm sorry, you cut out there. Can you say that again?
Oh, yeah. Functionally for this loop, it will be the same.
Yeah, go ahead, run it.
Bye, Drop Bear. Thanks for stopping by.
Bye, Drop Bear.
Drop Bear is awesome. Yes. Okay. So it worked.
Okay.
And I'm also going to copy this. So I think just because of the structure of this, it makes sense that it would kind of evaluate the same. But I can see how you would get into trouble. Like for certain loops, I can see how you would get in trouble with the fact that it evaluates first.
Yeah. And sometimes this is done. There's different reasons why the language authors originally wanted to put this there. I mean, the general thought was that sometimes you want to run a loop no matter what, even if something is false. It's like, so even if you only want to do it once, it'll go. But in the case of like the while, you might not ever run it. You know, you might do while,
right,
you know, something false. And
I use while a lot with like scoring and like almost, yeah. So I kind of get what you're saying, where like you might always want to run a loop, but there's going to be cases where you want it to you want it to be a conditional. It's almost like if then, but you don't want to code out all of the different ifs. So while is like a neater way to do it.
Yep. Yeah, that's one way.
Also, Strophium's totally right.
I just saw Moshi's comment. I actually didn't change anything on my end. I think I'm just guessing that it's probably related to the instability that from Twitch and Twitch being out earlier. So it seems like Loafbone ran into this problem earlier and was lucky when on a reconnect that I got a different server. So Strophium saying with object-oriented programming, I shouldn't say OOP, it could be semantically necessary
and
because object performing its function could be the thing that's generating the termination condition. Yes, it's true that this actually does come up more in C++ than it does in C, but for straight C, it's relatively uncommon to see it. It'll occasionally happen with file semantics, but generally speaking, anything that you can write in a while, you can also write in a do while. The only real exception is whether or not it's going to run this thing every time, even if the condition's false. Like, so in the case, I'm sorry, I'm selecting lines. She can't see selections.
I'm watching stream, so I have it.
Cool.
Yes, you're fine.
So the body here would be executed no matter what, at least once in the case of the do while. But in the case of the while, if the condition's false, it'll never be executed. You could just copy it and put it up here if you wanted to. The spacing is really going to drive Strophium nuts. So just to kind of fix that so that Strophium's happy. This is kind of more standard syntax. So, okay. So those kind of make sense?
Yeah.
Right.
Yep.
I know it's a quick version of it, but I mean, I'm kind of assuming like the Python background and, we're just sort of translating that stuff into C. Okay.
Yeah, it really does, especially with the loops. Like I honestly, I know I've before, but I love the sort of three argument format. Yes, yeah. I like that so much. It's explicit and it's just all right there, and it's so nice. And Python needs to copy that.
They are strongly against it in Python.
Oh, you know what? I love Python, but that's like Python's wrong.
Okay, we sorted out Okigon as well. It's funny how like the spacing was throwing them off, and you're a Python programmer normally, so how the Python fell fast from you. You're like, spacing, I could do whatever in C. I mean, I could just be like,
what was the spacing? I don't know. Wait, where was
just
was it back all the way there?
No, you had it. It was one off. So
it's really hard to see in this editor for me, but
don't worry about it. Yeah, I don't have any, there's no visual indicators about like that, but anyway, we also don't in C tends to be a lot more compact, so typically this would be written more like this. Related blocks tend to be all together, like they typically don't get much spacing. Python is sense. Kind of like Python specifies that there should be spacing, like it's one of the peps.
Yeah. So. I find that easier to read, especially if I'm learning something new, just to have it kind of spaced out, but that's just me.
To Strophium's comment, C programmers like to make their code look as complicated as possible. I would say that that's not entirely true compared to Perl programmers. But I had to do C because I had to while because BCPL had.
Well, I've learned already from my sort of programming gurus that the hardest thing is not to make your code look difficult, it's to make your code extremely readable.
Yes, it's a very Pythonic stance, by the way. The C people do not have that stance in general, by the way.
Well, I like it. I like that it's less about looking as complicated as possible, and it's more about
Come
being
on, we're
readable.
writing C. We got to make it look complicated. I agree with Strophium. All right, so
We'll agree to disagree.
no, I'm trolling. I actually do agree with you. Okay, great. Let's get to
Strophium.
Oh, totally. Let's get to the other part of the business. So, fixed types. What are fixed types? What types do we know about right now?
Int, char, and strings. Well, strings is sort of like strings of characters. I don't know if that's like an explicit type, but
I'm going to give you
that's kind of what we
a
know.
lime green here.
And we've talked about other stuff like longs and shorts or something. And
what was the last one you said?
and
Int, char, and what?
string.
There's no string type.
Yeah, so that's why I said is I'm not sure if it's actually a type or just a string of characters, but
Yes, this isn't C++. We don't get string as a type for this. Okay, so right, and then you started mentioning some of the other types that we have done less with, like floats and double the size of a float because double, and double the size of an integer because long. Now these are all signed types.
yes.
As we kind of digressed in the second episode, it doesn't really make a lot of sense to talk about a signed char, but char on its own is a signed type, I should say, as well. You can have an unsigned char. I mean, it's valid. You can slap unsigned basically in front of any of these, and you'll get their unsigned counterparts. So you could say unsigned int, unsigned long, whatever. That all works, but like I told you and warned you very quickly before, this wasn't really a standard size in a lot of the original implementations. So things that created a lot of trouble, and partially because like the original standard on an int was convenient. So this was something that was a convenient size for an integer on your platform, and that was mainly because the standards were not getting specific about like how many bits there were in a byte. So like back in the day, you might say something like, a character, how big was a byte? Well, the answer we typically whip out is it's 8 bits, but that's not true on some platforms because sometimes a byte is 12 bits. Or maybe you have a nibble platform where it's 4 bits, or you might be dealing on an 18-bit architecture because somebody was really just having a little too much sauce. I don't want to get into the reasons. Okay, but the fact is, this was kind of very non-standard. The standards committees all moved away from using this term at all, and they just started referring to octets in general. And that was very clearly 8. So that had a really nice name, but C was already created as a language. And when you started saying like, okay, how big are these different types? We very quickly touched on an operator, the other class. Do you remember what it was? To see how big something was?
Oh, shoot.
Good job on shoot.
I try so hard. It was like get size or thing.
It's very close. It's what is the size of this type?
There we go. Okay, yeah, size of.
Okay, and we can specify either a type directly as a cast, which is we just put it in parentheses, or we could just specify the size of a variable like z. So if I defined z to be an integer, and then I do a size of z, that's fine. Okay, but the parentheses are not required in this case because size of is actually an operator in the language. It's not a function, no matter how much we want to make it a function. Okay. Oh, and sorry, I just realized I missed a bunch of things in chat. Yes, Panos, I agree with you. She's also a streamer, so she has a streamer voice. C doesn't have streams. You have Carestar. Yes, Strophium got that. And not going to comment. Got documented somehow. Yes, Tyler. Who needs indents? Just need less lines of code. Mary is right. Think about punch cards and the other ways that you could write this back in the day. So,
oh, Lord.
And yes, Okigan quoted a famous gem in this space, which is, "It was hard to write it. It should be hard to read it."
Oh gosh.
Sorry, that got old man voice automatically. um, and yes, by the way, Nathaniel, like I'm not talking too much about the newer standards because that's not going to be a lot of the C code that she sees. Most C code is going to be pretty classic. Okay, so this back to brass tacks. We can look at the size of any of these things directly in the language, and int ended up later on getting standardized as 32 bits, which is the same as 4 characters. And a char was defined as 1 byte, which was problematic. And a short was defined as somewhere in between these. So if I built like a size scale of all of these things, long was sort of the big one. I'm not going to talk about the IEEE types, which were added later. But a long was sort of the big one. And then, you had sort of at the other end, you had like a char. There's no notion of a bit or a byte. There's no bit type, but there are some unary bit. There's bit fields and stuff that we get into a little bit later. And everything is sort of on the spectrum between these two. Okay, so int most of the time is the same size as long, except when it isn't. And
Okay.
short is most of the time twice the size of char. But except when that sort of fell out of use. This was sort of more in the era of like 16-bit computing. And it never got as much love as the other types. Int used to be the size of a short in some older compilers, but then they realized that's kind of crazy, and then they made it the size of a long until that was all fine when we were in the 32-bit world. But computers these days, how many bits do they have?
64.
You got it.
Okay, I'm like, oh shit.
Most of them are 64 now. So what do we do? Well, we could just make this long 64 bits, and then that's fine. Int will just sort of stay 32 bits sometimes, except on other compilers where it'll occasionally follow the 64-bit thing. And int over here, well, it's pretty much always going over there. And short sometimes is just short. And then, but we need to have Unicode, because what do you do with characters that are from like international standards? They don't fit into 8 bits anymore. So this whole character thing is kind of crazy. So then we get the wide character type, and then we get all sorts of other stuff that starts to happen. So I'm not going to get into this. This led to insanity.
Okay.
And that was bad. So a lot of programmers got into some crazy stuff to try to work around all of this like craziness. And so one of the things that they would start to do is they would start to say, okay, my long, and they would define their own types, is really 32 bits. And I don't care what platform you run it on. My long is always 32 bits. This was a fixed size. This turned out to be
because they set it.
Yeah,
is that what you
they
mean?
set it
yeah,
that way. Like, so they'd start doing all sorts of crazy tricks, which I'm going to show you that later when we get into those. But C is, it turns out from Coverity, who studied a lot of static analysis stuff in C, that C is not a language. C is very loosely a language, because everywhere that C exists, it's pretty much off standard in some way by using the standards. So that's going to start a fight. So I'm not going to get into it, but we can get into that later. And hello, Last Miles. How are you doing? I'm not getting into UTF-8 for right now, but that's actually Last Miles is bringing up kind of the solution that was sort of sane to all of this, which was, what do we do with characters when we want to start having global encoding? Well, there was originally this notion of a wide character, which was kind of non-standard, and it made it into a few of the specs, but there wasn't a lot of agreement on what those characters were mapped to. And then they said, well, we could just make everything really, really big, to fit like every possible character. And that kind of got crazy. So then they said, all right, look, let's talk about the glyph itself, which is like some particular character. Like, so, this could be like,
Oh, right. We were talking about this last week with how you kind of incorporate all of the different, like,
So
yeah.
here's the dragon in very fast scroll. So this
I see.
this is a glyph. It's not it doesn't specify a particular encoding. It's just that this character is dragon pretty much all the time. It's written in traditional style here. So we can worry about what character that is, which is talking about glyphs, and then we can worry about how we're going to encode that. And that really kind of gets into what constraints I want to worry about on my system. Like if I'm working in the Western language planes, then I pretty much want this to be like 7 or 8 bits per character. I don't want to pay a penalty to encode a lot of characters that are not going to show up in my data stream a lot. But I might want this to extend, so then I have variable length encoding like UTF-8, or I could go UTF-16, which is kind of common in the Java world, so you'll see this a lot. And then I could say, well, I could just make it big enough to cover every character, which means that pretty much everyone is wasting 24 bits unless you're, in the ancient Sumerian. So
is glyph kind of like a proper term there, or I mean, in linguistics, we would talk about like the kanji that you wrote to be like a logogram, and so
logographs, yes,
yeah, say it's the same term, it's interchangeable,
yeah.
But is that just okay? I think I'm following you. Sorry, I had to like. So this encoding that you're talking about is to basically represent all of the various systems of human communication. It's like all the different symbols,
yes.
And all of the different...
This is kind of the set of all characters. And then we can talk about the set of all encodings of those characters. And it's a little bit more complicated than what Last Miles is talking about. But we can... I can tell you a lot about internationalization later. So we'll get to this topic when we're sort of ready for it. But anyway, the moral of the story is that this didn't really work for our basic character definition anymore. So we wanted to move out of this world of these sort of like non-specific types and types that would change depending on what platform you were on or which compiler or which standard or whatever. And that's actually the creation of what our second topic is of today, which is our fixed size types. And these are related to these. They were designed to be kind of like quick to pick up if you were used to like the old style types. And see you later, Tyler. Thanks for dropping by. But they're actually incredibly specific, and they spell out exactly how big they are no matter what. So this improved portability massively, and they really punted on care, by the way. So they basically said, look, if you want to get into the world of all of this stuff, it's not going to fit into a type because it really depends on how you want to encode it and how you want to do your data processing. So that basically the standards body said, we're just not going to take a stance on that. We're going to leave character as pretty much 8. So then, that's actually what I'm going to show you over here, so these things have things which specify very quickly whether they're signed or unsigned, which is typically denoted as a U. And then there's a basic type. So this is our sign or unsign specifier. Then there's our basic type. And this is something that looks like what you've seen in the past. So that would be like,
for example.
Yes. uint. And then there's a bit size, just to make sure that this is totally 100% clear what this means. So the bit size is like 32 bits, and that means 32 bits. And I don't care how you interpret the integer, it's always 32 bits. And the specifier that we're using, the standard convention, the underscore type. So this style.
What's the underscore T thing? I'm sorry.
It's basically
I'm typing.
Just convention type, basically. Like this is to say that we're using the new style types because, some people were already starting to use like things like their own uints, and their own uint 32 and, whatever. So this just to make sure we didn't trip over that, we added an underscore T to the standard to say like, okay, this is new stuff.
Gotcha.
Okay. So character in this world, because like I just told you, doesn't really make any sense. because it depends on how you want to do encoding, and it depends if you want to use, Unicode 8, Unicode 32, or if you want to use something like Shift-JIS or whatever. There was a whole world of sort of encoding stuff they didn't want to get into. So they just said, this is now uint 8. So it's no longer, we want to treat this as 8 bits, and that's it. So this is an 8-bit number. So as we saw earlier when we were sort of warming up, like, we can treat characters as numbers, and this really just kind of formalized that. They said, if you want to add the semantics of a character on it, it doesn't really belong in the language standard anyway, unless you're doing like ASCII, which I think is pretty much in there. Okay. So, and then, if we drop this U, then that implies that it's signed. So, we can say like int 32. We can do this on a lot of platforms too, and actually spell out the S. So that's kind of implementation stuff we're going to get to in a minute. So, all right, high level, does that make sense?
I think so. I think so.
Okay. And Nathaniel, don't show her the dark magic yet.
Oh boy.
Okay. So I'm going to clear your program here, and we're going to bring this back to our learning interface. Okay, so all of these types are specified. They're specified in a few different places, but the way that I'm going to show you is we're going to use the standard numeric types, which is standard int. So this is very portable. It's available just about everywhere. Once you include that, you can now start using these new types. So before, when you were doing something like an int for a counter, and you really meant, something like this, which really sort of implied that you were probably going to use it unsigned anyway. Mm-hmm. We could actually be explicit about that now. And we could do something like this. You'll notice it changed color as soon as I drop that T in there.
Yep.
So, and this is going to invoke the new style. And if we want to look at the size of these things, I'm going to lose the glove for a moment because I think we're good on whiteboard stuff. Then this is going to be so I didn't show you this specifier, but basically we did D for sort of decimal.
Yep.
L implies that it's long, so it basically just usually means double the size of whatever the type is.
Okay.
So it turns out that they actually added a new type, which is this.
What?
And this is basically, I'll get to that in a minute, actually. That's getting a little bit into standards stuff. But if I take this thing and I run my size of operator, I can add a cast here and basically just say like, okay, show me the size of, actually I won't do the cast. I'll do show me the size of I. Okay, so what are we going to see?
So the default.
Well,
I don't know what the default
question.
is for int.
We have no idea because it depends on what platform. I can tell you that it's going to end up being the same as this other type, but that was kind of the old world of sort of less standard types, and that depends on which standard you're using. So now we're going to use these new style types, and it's 4. Now it's 4 octets, so bytes.
32.
In the modern sense, which is 32. Okay, so that's our 32 bits. Now, so I told you before, a character turns into a uint 8. So there's your single byte type.
Yep. Okay.
And there's all the different variations of this. I'm actually gonna you don't have to take too many notes because I brought up the Wikipedia page for you.
Yay!
Which has both the basic types and the new types. So this kind of like, if you get into this other stuff. That when you start getting into like 128-bit computing, they realize like this is just craziness. So like Like, how do you define a long? I mean, is that using the 32-bit long? Is that, so anyway, this is something that we can use in new code to specify types that we want some precision on size. So we're still being a little bit old school because we're using the standard convention. Actually, this should have these. I don't know where that went to. But we can actually move to the other stuff. Yes, Strophium is right. Standard long time ago in a galaxy far, far away. So these are like, you can think of these as the portable new types, and that's, if you're writing new C code, you probably want to be there, as opposed to using the old style types. I'll use whatever. I mean, you're kind of making a judgment call on like where your program's going to live. And one of those funny things about programs is that there's no more permanent program than a temporary one. No more permanent solution than a temporary solution. So be careful. But so if we want to do our basic like loop counters and stuff like that, we can use, this is basically our care, if we're thinking about it. And now we don't have to worry about signed anymore versus unsigned. We can be clear, or we can just drop it. And I think this one is, this is going to be fine. And I think this is no longer, I think this was rejected. Yeah. Okay, good. And you get your error messages in your output, which is very nice.
Fancy.
Okay, so this would be the direct equivalent of your character type. So let's just bump this back up to our normal sort of int, except we're going to go with the unsigned version of it. And now, why don't you give me a loop counter using that J? So let's do a simple print the first 5 numbers again, but using the new types.
It's going to be no different, right?
Well, except for the type specification.
But you already wrote that.
Well,
yes.
I'll fix that for
you. No.
Problem solved.
I think there's an underscore T here. Okay. All right. There we go. Yeah. Let's make that 0. Okay. And then.
Yeah, it'll change color when you get it right.
That's helpful. Okay, so let me start. That's not a brace. Back. Oh. And what did you want it to print?
Let's start with our hello world, which is our first 5 characters of the alphabet.
Okay.
Okay, we want to be fancy C people, so we can put the type specifier right in the...
Yes, I just remembered that.
Like Strophium says, we got to write it to be as hard as possible to read. Now, this is actually good for scope reasons we talked about before.
Oopsies. What? Oh, maybe I need to like stuff. Yeah, okay, that's what I thought. There we go.
I'm gonna clear your output so we can see its beauty. All right. What are we forgetting between these lines?
Which lines?
I mean, in the output. That.
The new line, but how would I put it with put care? I don't think we ever did that.
It's actually just a character, so it worked. We didn't actually do it with put care, but it works the same as with printf. Yeah.
But in printf, we have we have the string quotation, so we can have more than one character. Because here we already have.
No, we need another put care.
Yeah, that's what I thought. Okay, because you can only have one. Yes,
that's correct.
Okay. That makes sense.
Yeah, it's just a normal character.
Okay.
There you go.
Woohoo!
Okay, so new types, we know why they're beautiful because they tell us exactly how big they are. no portability issues with sizes and whatever. And this is kind of the future. So I'll just drop you the link to this on the Wikipedia so that you can go look at all of its wonderful gory history. But all right. So how do you feel about that topic?
I feel good. I mean, I think it's
practice like anything else, right? I mean, we need
and I think
it, but
all of the different types, like the fixed types that we covered today, I think it's going to take me a little bit of, I don't know, practice before I kind of intuitively want to write out this long, weird type instead of just saying int. So I think that'll just take practice.
I'm not really going to ding you either way in like your first taste to C course, but this is definitely like if you're as you're doing more C, like you're definitely going to want to be using the portable types because reasons. I think later on, I'm saving this for you. We're going to go into the libpng code, which is written in C for decoding PNG files, like, PNG images. And you can see some of the battle scars of the history of,
oh boy,
of all this stuff. Okay, so good. Well, that means we can get into topics, right?
Woohoo!